let's start today's session. Welcome to Amateur Astronomers Association. Today's topic is mysteries of solar system. That is about small bodies of the small solar system. Today's our guest speaker is Anand Ghaisas, uh, who is actually a retired scientific officer from Astronomy Olympiad Cell, Homi Bhabha Center for Science Education, TIFR Mumbai. He has worked on various projects of HPCSE for training students, teachers, and parents on conceptual clarifications in science, mathematics, and astronomy. He has held a lot of overnight stargazing observation sessions with telescopes, taught handling of telescopes, how to look at the sky, knowing about the constellation, zodiac signs, and all other things like finding North Star. Uh, he has worked as a conveyor and mentor and as a judge in International Astronomy Olympiad examination held at Ukraine, Poland, and China. Also worked as a paper setter for Earth Science Olympiad sessions. He has written almost 40 plus books in Marathi on experiments in science and astronomy, out of which four books were awarded as the best writing in science for children's award by the state government of Maharashtra. He has also worked as a science advisor for TV shows for Poco channel called FAQ, for National Geographic channel for Science for the Smart, DD National channel for Chamatkar, and prepared many episodes for the educational channels on DD Marathi channel. Also has written and presented many programs for All India Radio and written many columns on science in Marathi and English newspaper, which are still going on. And we all wish him to keep on going and sharing his knowledge, his experience about the science astronomy subject to all of us, so that we can learn more and more. So as per the today's topic, mysteries of the solar system, which is AstroTalk 35. I welcome Anand Ghaisas sir to give his session about the smaller bodies of the solar system. Over to you, Anand sir.
Namaste. So, shall I start now?
Yes, sir. Yes,
Intro?
yes.
The first slide shows many bodies in one sequence. I have taken the biggest body here as a Earth. So, when we call something is smaller than us, that us is Earth. Okay, that is my concept. So, what is smaller than Earth? So, we will start from Moon basically. Why? Because the Moon is the biggest, uh, one of the biggest uh, satellites of our solar system. So, we'll start by that and then go ahead. But first, let us share the slideshow and then we'll go ahead. So, can you see uh, which smaller bodies, satellites of main 8 planets, after Pluto's deletion from the group of planets, the remaining dwarf planets or Plutoids, then asteroids. I'm actually not going more detailed things in asteroids in this talk, but just mentioning them. Then comets, then satellite of dwarf planets. They are also in larger quantities. And satellite of satellites. I'm going more about this because this is something mystery, that there is a satellite and the satellite has got more satellites. So this is a funny thing. So that is a mystery. And meteorites and meteorites. So these are the things I'm going to cover, and I'm going ahead with the mysteries of these bodies, some mathematical mysteries, some positional mysteries, and some basic designs of that uh, bodies. So how many satellites are there? No satellite to Mercury or and Venus. So Earth has one. We call it Moon. Actually, many persons they call all satellites like Moon. So moons of Jupiter, moons of Saturn. That is a wrong notion. You should say satellites of Jupiter, satellites of Saturn, like that. So Earth has one only, Mars has two, Jupiter has 95. When I say 95, four bigger Galilean moons and others smaller, but they are vary in very much their designs and their orbits. Let us see that. Now Saturn has 274. Actually, for Jupiter, there are more discovered, but they are not named and they are not yet been logically thought that they are satellites, but they may be wanderers. We don't know. So when the basic orbital positioning is decided, then only they have been listed. So Jupiter has actually at today in present situation at 1002 discoveries, but only 95 are called uh, as their satellites. Okay, Uranus has 28, so six large and others small. Neptune has 14, one bigger and other small. Pluto has five, one bigger and other smalls. Okay, now Aries. Now this is asteroids. Aries and dwarf planets. Haumia, Salacia, Varada, Makemake, Orcus, and everybody has a satellite. So there are each one has one satellite, and Haumia only has two. But totally 236 satellites are known and listed now, but the number is now going to be increasing. So let us see about that also. So we'll start first about the mystery of the moon, our moon. So when we say that moon is actually revolving around Earth, that is not the case. It is a system. The moon and our Earth both are revolving around each other, and the barycenter of the Earth is revolving around the sun. That is the correct case. Okay, so mystery is that we think that somebody is going around somebody, and that another thing is going around the third party, which is a bigger thing, but that doesn't happen really everywhere. So there may be many things involved in gravitational waves. So, and because of that, here you can see that moon is here, and the earth center is not on the on this path. Okay, so earth is going like this, and moon is traveling like this. See, it is going here, 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 and then up. So sometimes earth is nearer to the sun, sometimes moon is nearer to the sun. So they are going actually shifting their positions every day. So that is the beauty of that. That is a mystery. But another mystery is something like this. Okay, so everywhere you just think of their planes, they are they are slightly different. So if we think our earth is like this, the axis is like here, so this difference is 23.5. Okay, but the plane is here, earth's plane is here, so the plane of moon's rotation is slightly differing, so it is up here 5.15. So axis here differs, and there is again moon's axis differs, so it has slightly 1.53% tilting, and the barycenter is at the center. Okay, and both are moving around it. So this thing is happening. And another thing, a beauty, actually we don't know here just now, and we don't bother about it more, but many years back people were thinking more about it, about the sizes of the moon and earth. Why? Because it was the first nearest object. So moon semi major axis is 3000 3,84,399 kilometers. Okay, but it is again, see, this is the nearest point, this is the farthest point. diameter is this much, rotation is now everything we know here. Okay, this is today's understanding. But what differing things are there back sometime about 100 years back is something mysterious. So see the size of the moon when it is near earth and when it is far earth. Okay, and how this rotates and how it actually happens. One second. Can you see, because of that tilt of moon's axis, the mystery is it is not stable. Sometimes the left side is seen more, sometimes the right side is seen more here. So the moon shows more than half always. And then again, one mystery is it is always facing towards earth only one side, the other side is not known to us really. Okay, our probes have gone on the back of the sun, but we don't see it daily. Okay, why? Because the rotational period and the revolutionary period both are same, and we know that we have crescent moon and all that, and why that happens. So, and only two things happen here in our condition is a total solar eclipse. It doesn't happen to any other thing, any other satellites. Okay, total. When I say total solar eclipse doesn't happen. But here also we see a partial and also another type of hybrid also eclipses of moon to us. So that is a mystery, and it may be changing because moon is slowly going away from earth. But another thing mystery is if you just place moon on the top of the size of the earth, see the geometry. The geometry of earth and moon is something fantastic when measured in miles. Okay, these all numbers are in miles: 2,160, 7,920, 3,960, 5,040, and 1,080. Do you understand what is similarity? So if you just take all these, they actually goes towards a number called 9. That was a mysterious number, and it was very much uh, accepted at that time. So let us see Earth and Moon relationship based on the number 9. Why? Their measurement taken in the units of miles, if added together, give the number 9. How? In ancient times, they believed that this number had a mystical significance and that this number has been everywhere. That is why they considered these numbers to be special and use them in architecture, painting, music, writing, and all religious matters. 9 has a special place. These numbers were, I have given the numbers. There are some. So see 1080 means 9. 1 plus 0 plus 8 plus 0 is 9. 7 plus 9 plus 2 plus 0 is 18, and again 1 plus 8 is 9. So that is the mysterious thing. At that time they understood it. The number 27 is a cube of 3. Okay, if you reverse it, it becomes 72. The moment of the equinox on the ecliptic is 1 degree every 72 years. So they have also the relation with 9. So in contrast, the number 27 means that from the perspective of the ratio of the size of the moon earth, it comes out as 3 divided by 11 is equal to 0.27. So that was a mysterious thing. They were actually appreciating it as a funny thing, but it was used in many literatures also. Again, Earth Moon relation. If we take a right angle triangle with lengths of 3, 4, 5, then its area is 6. If these numbers are added and multiplied, the numbers obtained represent the relationship of the Earth's measurement to the moon. For example, 3 plus 4 plus 5 is 12, and 3 into 4 into 5 is 60, and 12 into 6 is 72, where 7 plus 2 is again 9. Now 72 into 10 becomes 720. If we multiply 720 by the numbers in the moon earth ratio 11 to 3, the answer show the relationship between the lengths. All lengths I have shown in the previous picture. The radius of the moon is 1080. Diameter of the moon is 2160. Radius of the earth is 3960. Center of the earth from the center of the moon is 5000. These are all in miles. Okay, remember this. So isn't it fantasy? Really, it's a mystery how this actually happens and why. So, how many moon missions? Let us go. 123 moon missions have been launched to the moon. Out of these, 56 have been successful and 67 have been failed. 52 have been near moon missions, 68 have been orbiting the moon, and 10 have been missions that have landed or impacted objects on the moon. 9 missions have included, see again 9, of these, two have satellites orbiting the moon, four have been people walking on the moon, three have been vehicles or vehicles that have been used to walk on the moon with spacecraft. The first attempt at the lunar mission was made by United States on August 17, 1958. The first successful lunar mission was by Soviet Union in September 1959. India Chandrayaan 1. See, October 21, 2008, it was the 115 mission. India Chandrayaan 2 mission was only partially successful. India Chandrayaan 3 was successful. And till today, we are operating. Now, if you just go to the inside of the moon, then you see that maybe iron core here, outer layer of viscous magma, but here there is a thicker crust, and here there is a, but thinner crust is toward earth and thicker crust is outside. Again, why? We don't know. We have to go and think about it more, and probe has to be sent and seen actual settings there. So Chandrayaan 1 has 3D view of the moon, and we see many such craters on it and have a 3D map. Now again, when we put this aside, moon aside, and go ahead, then there is a one fantastic thing we see that is called Lagrangian points. When there is a two body problem, this is sun, this is earth. Okay, so in between we call it as L1. This position is called Lagrangian point 1. This position is Lagrangian point 2. This position is Lagrangian point 3, exactly opposite the Earth. Then there is a point called L4 and L5. These are basically a beautiful thing in here. All the smaller bodies, they are captured here. Why? Because of the equal distance from both the bodies, bigger bodies. So from here, L4 is on exactly 60 degrees. 1, 2, and 3. So these three sides, if you calculate, then it is a equilateral triangle. Okay. And how it happens? They move. All the points move around the basic big body which we call sun here in our solar system, and the 4th and 5th position is not changing. And at this point there are many satellites, many smaller bodies they have captured there, and they are actually moving around on the orbit of that bigger body, which is we call it planets. Okay, so let us see the mystery of these planets. One first mystery is Earth. So there is one planet or planetesimal or moon or an object which has been captured by the Earth and the Sun at the Lagrangian point 4, which is here. Can you see? Earth is here, which is going around like this, and there is a one point. That simple point is going around like this, which is always ahead of the Earth. Okay, going ahead of the Earth as a Trojan, and Earth is following it. Let us see if we can see that. Oh, sorry. So it is a captured asteroid going ahead, a smaller body of just 6 kilometers, very small, but that is going ahead on the orbit of Earth, and Earth is following him, the asteroid 2010 TK7, a mysterious thing. A similar thing happens with the Mars. Okay, Mars has two uh, moons, we call it satellites. One is Phobos and one is Deimos. And our Mars Express orbiter is shown here. Why? Because it has came exactly in between these two. So it is, so when it is in that position here, it has taken some photographs. So this is Phobos, Deimos. So what happens? Can you see? So one satellite is moving faster than the other, and which is taking over, actually going faster. So this has been, so if we go to the Mars, then we observe these two satellites going like this. Isn't it beautiful? Yeah, but mysterious. So this was discovered by Asaf Halls from 28th August to 18th August 1877. So these are all details. I'm not going ahead with all the details, but the revolution size is the revolution. See, 7.66 hours, and this takes 30.35 hours. Okay, we'll go ahead towards Jupiter. So four bigger moons. If we see them from here, this photograph is taken by me from an 8-inch telescope. So we see them like this, but a beauty that an animation which is created from the notes by Galileo, directly you can see them like this. So these are the notes taken by Galileo himself day to day. So he has just marked the position of Jupiter and the position of its satellites, the four satellites, Galilean satellites that we call them Io, Europa, Callisto, and Ganymede. But Now, I have already said that Jupiter has not four moons. Jupiter has bigger four moons and other smaller are total 95. So let's go there. Jupiter satellites, there is a classification of this. Out of the total 95 satellites, 36 irregular satellites have not yet been named. The satellites closer to the Io's orbit are in the equatorial plane and in circular orbits. Io, Europa, Ganymede, Callisto are famous satellites discovered by Galileo. There is a group called Himalayan group. 11 to 12 million kilometers apart, these satellites are. Anand K group is retrograde satellites with a diameter of about 21 million kilometers. Carne group is retrograde satellites with a diameter of 23 million kilometers. Pacific group, most distant, 25 million kilometers and more. Themisto and Carpo are orbiting but not belong to any group. So that is again a group which is not a group. Themisto is immediately after the Galilean satellites, while Carpo is on the inner edge of the Ananke group. About 100 other satellites which have been seen once or twice are not yet listed. So this is the condition of the Jupiter satellites itself. And there are, see, there are three here. There are one, two, and three. The first is called Halo, and these are called Gossamer rings. Okay, in between these rings there are eight satellites. Okay, within the faint rings of Jupiter. Bigger are Thebe, Amalthea is here, and Metis is here, which is the nearest one. Actually, Adrastea and Metis, they belong to only one orbit, basically. Both the satellites are on one orbit. Some mysteries, I don't know. And if computer simulation has been taken of Jupiter's satellites, all four satellites are here, and all other satellites are like wanderers here and there because some are retrograde, some are tilted orbits, some are exactly opposite orbits. Okay, so this beauty is there with the Jupiter satellites. Again, one mystery is, see, Io 1, Europa 2, Ganymede 4. So when this moves, Ganymede takes one round, Io takes four rounds. So 1 is to 2 is to 4 is the is their moment, ratio of the moment. Why these ratios are there? We don't know again. Mystery. Perfect. Io, Europa. Now, Europa revolution is 3.5 days. Okay. 10 to 15 kilometer of icy surface here we see underneath approximately 160 kilometer deep ocean of water. This is smaller than moon but 50 times brighter. Smaller than moon but 50 times brighter because the surface is all ice, water ice. If you see the surface from near, the Europa shows shifting icy blocks going here and there and cutting their lengths. And if you go still near, then we see like this. Everywhere there is a moment on Europa. And then if you see Ganymede, there are bigger patches. This is also a icy surface, but clearly not yet understood the colored patches on the surface, but under the icy surface there may be a salty ocean and a stony core inside. So this is Ganymede. Callisto has totally different. Again, this is also a icy thing, icy water surface, but this is not. This looks like a muddy thing. Why? See, the surface of Callisto is seen here as if many stones are thrown in a wet, muddy sand. Okay, this is the image was captured by Galileo probe. Then we go to Saturn. We go ahead to the Saturn. Then we see beautiful Saturn with the rings. But the rings are not positioned A, B, C, D like that. The A ring is outer ring, and D ring is the inner ring, and C B is the second outer, and C is second inner. So because they are actually named how they are being discovered. Okay, so but see all the things, there is a division here in the NK division, there are two divisions, then Mimas, Encedas. So these are very, very far away. And all these satellites have a beautiful thing of many satellites. Let us go ahead and see. There are Schaefer satellites. What is Schaefer? Because these rings are kept intact by keeping two satellites. One is ahead, one is behind. So Atlas is at A ring. Daphnis is in a killer gap inside here. Okay, and Pan in NK gap. So in a gap there is a satellite. Actually the gap is created by the satellites because he has removed all the orbiting material in his path, and also he is actually holding all the other material at a safe distance, and because of that the ring is plane in one plane. So like this. So Pandora and Prometheus. One is inside here and one is outside here. So these are both are called Shepherd satellites, and both are holding these F ring. Can you see that there are some waves in that ring when the satellites are moving near? There is a structure of some twisting of the rings. Again, why these twisting things are happening? A mystery. Another mystery is this is called orbital sharing position. Okay, so here Epimetheus is actually going like this, going like this, going like this, but the total orbit is same. But here one is actually orbiting like this. So when this is inside, this is outside. When this is inside, this is outside, and both are sharing this. So one orbit sharing by two satellites and going halfway. If you say it is like halfway, going ahead and again coming back, going ahead and coming back again back in that orbit. Mystery. So these are actually the Janus and Epimetheus. Mimas is again one beautiful satellite of, but why this? Why this? We don't know. All the surface is hit by something, and they have lots of uh, craters on it. But now, if we go ahead, the comparison of Enceladus is smaller than that, Mimas, but Earth is like that, then Enceladus. But this is a beauty. Enceladus has one surface is more plain, and here at the bottom there are some scratches. Okay, why these scratches we don't know. Surface here is plain, scratches here are there, but in those scratches something is oozing out. There are geysers like this. So actually water is thrown out. Why and how? These are the geysers on Enceladus. And we think that how it is happening because of the tidal pressure. So tidal heating happens here. The pressure is building here on the hot rock, and because of that a pressurized liquid gas pocket has been happened. It is H2 only, but there is some vent, and then the geyser, the H2O vapor plus ice particles are actually geysered out. So we call it Enceladus cold geyser model. Okay, but this is just a theory. Actually, what is happening, we have yet to find out. Then Titan. This is the biggest moon of satellite actually, moon of Saturn actually. So, but can you see that the half part, the upper part is slightly dark and the lower part is slightly brighter? Why this is, again we don't know. But there is a distinct tint difference is shown here. Okay. And one probe has gone near, Cassini probe has gone near, and it has seen a transit of, see, the sun is exactly on that side. So clearly shows thus. Here all this is the atmosphere of the Titan. So Huygens probe has lowered and landed on the surface of the Titan, but when it was landing, it was going through the atmosphere of Titan. This photograph was taken by it, and this is a not a actual picture, but a concept, artist concept that Huygens has been landed over the surface of the Titan, but this is also a concept, but which is taken by many photographs putting together. So on Titan, this is lake, but lake of methane. Okay, lake of methane. So the total atmosphere is also made out of methane. But there are many amino acids involved. When we say methane, then it relates to many things. Why? Don't know. Then see, this is Saturn, and there are two beautiful things, Dione and Tethys. Dione and Tethys, they are also exactly Tethys and Dione. But Dione has one and two, Telesto and Calypso. These are two satellites on the points of L4 and L5. So the satellite has two satellites. So Dione, and there is again Helen, another thing, Helen and Polydeuces. So it is 4 and 5. So when we tell that there are satellites to satellites, there are two satellites to one satellite, and that one satellite it is a satellite to a planet. So this refers Helen, and let us see how it actually. There are three things. Helen is here. It's going up, going down, going up, going down. If we say that this is Saturn, which is not going anywhere. Then Helen is moving like this. Polyduces is going like this. Actually, it is moving like this. Okay, like this, like this, like this. Okay, see, it is going on a circle and going here and there. And this is Polyduces here and there. So, Helen and Polyduces. Helen is here. Then comes Rhea. Saturn has many. Again, its revolution and rotation is same. Rotation and revolution 4.5 days. Why so small and why exact? Iapetus. Iapetus has this fantastic thing. Do you think somebody has sprinkled it with a dirt? Why these dirty blackish stains? We don't know. And on that blackish side, can you see here a slightly a hump here? It is not here. Okay. Why? This is a ridge. This is a total ridge halfway, halfway to that on that satellite. A mystery again. Exactly on equatorial plane, exactly covering halfway of that satellite, there is a ridge, and another side no ridge. Why this has happened, we don't know. Let's go ahead. Okay. So the Pluto is something like this. So everything is like this, but Pluto is very far away. Why? And a Hyperion satellite of the it actually goes up to there and come back. Okay, like this. Then Phoebe and distant satellites of see Iapetus is here. Okay, and red orbits are retrograde like this, moving like this, and blue orbits are prograde. So there are more retrograde than prograde. Saturn's satellites are also divided into 11 groups. Some called moonlets, 30 to 800 meters in diameter, 7,000 in one ring. The rest are minor satellites, over 1 million. Two Shepherds, those who maintain the rings, mono-orbited, moving in the same orbit, changing orbits every 4 years. Inner large, Mimas Enceladus, Tethys Dione, Alcyonidae group, and The, Palen are three satellites between Mimas and Enceladus. Six Trojans, Telesto, Calypso, Tethys, Helen, and Polydeus and Dione. So these are 222. Okay, and then outer large Rhea, Titan, Hyperion, and Iapetus. Why they are so distant, irregular? Satellites are more small, distant, oblique, orbital planes, reverse motion. These are similar to captured asteroids. Now I am not going to say about asteroids. Okay, let's go. Some Inuit group, ninth. Okay, they are like this. So each one has given a color. So Ijirak is this is this is this, and this is green. Okay, no, sorry, this blue is here. Then 10th is Gallic group. Their movement is also some retrograde, some prograde. And then Norse group. See the number. In the Norse group there are 197, a total of 46 counter rotating ones in Phobos group, and other names. and again plus 25 unnamed satellites. So these are the conditions of satellites of Saturn. Then comes Uranus. Why Uranus? Uranus, again Uranus, there is three different things. 13 inner satellites within the rings, 5 larger satellites outside the ring, about 9 more distant satellites with irregular orbits, mostly revolving in opposite direction. Why the outside satellites are in opposite direction? Don't know. So if you take Uranus like this, then Puck, Miranda, Ariel, Umbriel, Titania, and Oberon. Now these are some fantastic features. In on Miranda, actually some chiseled thing. Somebody has been already doing some work on that and also cut it. Just like cut marks are here. Why these are cut marks? Why these are, see? Can you see? Can you see marks here? All these marks are something is going on. And here there are large craters and valleys. Why valleys? 10 kilometer deep valleys are there. See, somebody has been actually going ahead with some machinery to take away the material from there. And these are actually the cliffs are actually the cliffs are actually 10 kilometer in diameter, 10 kilometer depth. Mystery. And there are satellites which are going in different things. So we go to Neptune. Neptune satellites are Proteus. One is bigger and one is very smaller. Why again? And these are not actually giving you the exact sizes because not yet discovered correctly their sizes. Okay, so equatorially inclined satellites which lie within the orbits of its largest satellites, Triton. Then distant satellites which lie outside the Triton's orbit, of which three are inclined and three are retrograde. Again, Triton. Now here the surface is different. Here the surface is different. Mystery. It is mysterious that the half part of this, half part means one fourth part of the total satellite is a different condition, and all up here is different condition. Why? Not known. Revolution is retrograde, 156.8 degrees tilted orbital plane. So the planes are also not equatorial. See, satellites orbits of Uranus outside the orbit of the Triton is, this is how, this is one here, and all this is up here. This is going here. This is going here. See, the moments are not equal, not exactly similar to each other. They are totally different. In their distances are different. Their orbital planes are in different conditions. Why we don't know. Okay, I was saying that I'm not going to say anything about asteroid, but some are beautiful. So 243 Ida is a beautiful asteroid which has one satellite. So I'm not taking this as a smaller body, but this as a smaller body. Okay. Ulkova 1. Now 90 Antiope has binary satellite. Sylvia has two, here two. Cleopatra has three satellites. Eugenia has three. See from here two and one, two, three, four. There are three. Here three. Each one has three satellites here. and Pluto has 5 satellites. So I'm almost completed the situation of all planets with their satellites here. But now what remains are like this. The Pluto, Charon, Styx, Nix, Kerberos and Hydra all are moving in one direction. See how many, about 100 or 1,000 satellites are moving retrograde and in different directions in between Uranus, Neptune. It starts from Jupiter. And again, if we go to Pluto, all are in one direction. Why these direction change? Everybody is in one direction. There is no retrograde here. Okay, that is a fantasy. And all the asteroids I have shown just now is this is called Ida. I have not given all the names. This is binary. Okay, see the size. See one, two, three satellite, and one is retrograde. Again, it is a difficult to know why this is happening. Though while it is not one way, then if we go far ahead, we call it trans-Neptunian objects, TNOs, which are one is Pluto. Now it is not said as planet, so it is a dwarf planet now. So these are two, Charon and Pluto, and one, two, three, four are smaller satellites. So totally 5 satellites to one. Here, Dysnomia is to Iris. Haumia has two here. MK2 is for Mekmek. Gong Gong has Jianglu. QR is Wayward. Sedna has no satellite. Wow. Why? Again. Orcus has one. Celestia has Actia. And MS4 again it has no satellite. So these are the known, and we know their orbital periods, we know their sizes. All these are dwarf planets, but we have to go ahead and discover many such things now. All things mystery. The number of comets is too large, and also the number of asteroids is also too large, and also meteor and meteorites have been not mentioned here. It will need a separate lecture, I think, because it is already 6 o'clock. 1 hour has passed just to see what is available in our solar system and their mysteries. I have not gone in detail mostly, and just given a thought for your curiosity and going ahead. Now, this is a beautiful picture I have got of one, and then asteroids, some examples of Dawn, Rosetta. Okay, you see here all these are Cassini, Galileo. Around all these is place, and some asteroids exploration. There are many now asteroid explorations are going ahead. So it will need a full much bigger lecture period for going ahead in the details of those smaller bodies. I think. Thank you.
Thanks a lot, Anandji. It was really a great session. Currently, we'll open the session for question and answers.
Yes. So I will just stop sharing the thing, and then let's go ahead with some question and answers. Thank you.
Thanks, Vijay, for your wonderful words. Really fantastic session. Enlightened a lot of unknown. Yeah, we know you have a question.
So Abhinav has raised his hand.
Yes, good evening, sir. We are now discovering many moons, natural satellites.
Yeah.
of many planets like Jupiter, Saturn. So means
Yeah.
how we discover them.
How we discover them? Okay, when we go and see see the telescopes are there. So from the telescope, if we go and see the near things of the planet, then we discover some spots going ahead and changing their positions with the background stars. If that happens, then we detect some object is there which is not following the course of uh, similar things but going ahead with another uh, actually we cannot consider it going ahead on something orbit or like that, but which orbit they are going on, that will take care of the distance of the main planet or main body and that small thing. And then we have to, if we actually if we see 3 points at different times, then we can calculate the orbital period of such an object and which is going about or revolving about that main body or not. Okay, so
Yes.
that way we discover the points which have been seen in the sky. So now there are bigger telescopes and also not only optical telescopes, there are radio telescopes. So on radio telescopes, many things can be uh, discovered. There are also infrared telescopes. We use many infrared telescopes to actually discover many planetesimals. Okay.
Okay. Yes. Thanks, sir.
So actually the change of the position around the background stars, because background stars are still there, they don't move. All the stars which are very very far away, they don't move. So something is moving in that frame. If you take many pictures of the same frame on some time scale, then we can calculate their distance and their positions with time lapse, and then we can continue discovering them. So first change in the position is more important to be discovered, and then orbits. And if the orbits are found, then actually there is a procedure to find their orbit is after 3 months. There is a basic thing that after 3 months you propose their orbit, and after 3 months, if that object is seen where you have predicted their positions, okay, you can, if you know that their orbit is okay going around here with a speed of this, then after 3 months it will should be here, not here. Okay, so if we get them there, then the orbit is known. Then again 3 months, so 3 times. With 3 months gap, if we see the object is moving along that special path, then they are listed as discovered.
Sure.
Up to that point, they are not discovered, they are not named, they are not listed.
Yes.
Okay.
Great, sir.
Vijay, go ahead.
Good evening.
Mangesh, sir. Yeah, this is one of the precious sessions that you have conducted. So many times, what we will see only planets and other things, but you've gone very deeper solar system, sir. Thanks, Anand, sir. My question: uh, after Jupiter, Saturn, Uranus, Neptune. So what I saw the photographs, all satellites are rocky, sir. So how they formed along with the formation of gaseous planets, or else they are dragged from the asteroid belt. My question.
Actually, how the objects are there, nobody knows. Okay, there is a theory that everything came out of a gas cloud and all the solar system has been formed, but their positions and their movement is totally different, and so the gaseous cloud, we can call Jupiter also as a gaseous cloud. Okay, because of the gravity, it has taken a round shape. That's why we call them planets, or uh, any object as satellites. And but there are various smaller bodies than that, which are called asteroids or comets. So they can be captured by these larger bodies, and they go around it after that. At some point they are captured with that uh, greater bodies, maybe gaseous or may not be gaseous. So then we call them as a satellite. So what we call it is totally different. It may be. So I always say that there are many bodies going around the sun, which may be captured by planets, or which may be captured by asteroids also, and then they become satellites. Okay,
Thank you, sir.
so how that have all the rings of Saturn is actually a satellite of Saturn, isn't it? Because there are many bodies, icy bodies, which fall around, and they are going in a equal position and equal orbit. That's why we call them uh, as a ring. But that ring thing is not actual ring, right? There are all particles. The rings are also made by particles, and that particles means how much? The in one ring there may be one particle which may be of the size of our building, isn't it? So all icy particles may be there. Okay,
Thank you, sir. Thank you, Mangesh sir, and thank you, Bharat sir, conducting a wonderful session. Thank you, Anand sir. Thank you very much.
thank you.
Thank you.
Okay,
Thank you, Vijayji.
and my phone number was given in the last slide. Again, I will just repeat it. My email is simple anandgaisas at gmail.com, and my phone number is 9867219455. And if you ask me any question on WhatsApp or email, I will give you the answer, written answer, and also with illustrations. I do it for many years, so I'm going ahead with that. So
Sir,
raise your questions, send me on email, that will be fine.
sir, could you please repeat the number?
Thank you so much, sir.
मी परत
Anand sir,
शेअर
can you
करतो माझा नंबर
put
व्हिडिओ
it again so that people can copy the number and
Yes, I will
email and
just
number?
The slides you can show,
I
sir.
will just I will just share the last. Yes. This is my mobile number, and this is my contact.
Thank you, sir.
So you can call me, you can send me emails or messages. Okay, thank you.
Nice session, sir. Thank you so much.
Anybody has any questions, or we are good to conclude? So with that, I would like to thank Anand sir for his wonderful session. Basically, the discussion was really enjoying, and we really enjoyed the exploring asteroid, comets, meteorites, and dwarf planets with such a interesting people to listen about it. And we definitely look forward or beyond the planets to uncover the hidden wonders of our cosmic neighborhood by saying keep exploring. And in fact, we are all curious about seeing about the planets and all things. So The next season we have actually kept a competition for people to observe at least some of the smaller bodies through the telescope.
Okay.
That is what like Cyrus, Vesta, or any large body.
Yeah, Vesta can be seen
Yes, yes,
in near future. Yes.
yeah. So that is what we are actually targeting, and probably if we can see it, we will try to capture it over a couple of
Yeah.
weeks, and so that
But
that
to see, but to actually observe Vesta, you need a telescope bigger than 6,
yeah,
uh,
we have 10 inch and
10
12
inch. Yeah. Okay.
10 inch 12 inch telescope. So we'll be using those to capture and see how we can do that. Okay. So
Okay.
thank you Anandji for your session.
Yeah.
Bharat sir, yeah, you want to conclude? Hello, Bharat sir. I think Bharat sir has some technical problems. He would
Yeah.
have
Yeah.
left. Yeah. So thank you for
Okay.
on behalf
We can
of Amateur
conclude now.
Sorry, sir.
We can conclude now,
Yeah, definitely.
and sometime some next session, one session can be on comets and asteroids.
Yeah, definitely. We look forward to you.
Definitely
Thank you,
looking
sir.
forward
Definitely, we look forward to
for
you.
that. Okay.
So thanks everyone for joining. We will conclude today's session. Thank you very much. See you next time. Thank you very much.
Yeah.
Bye.
Bye.